Follow along as we build a fitting tribute to the Land Rover Defender. This series is brought to you by LR Centre Limited and Frost Auto Restorers, as well as the help of SIP Industrial Products. Introducing our latest Land Rover t-shirt design, an ultra high quality comfortable cotton Kerry green t-shirt with a hand screen printed Airfix Land Rover sprue design. Check it out at shop.funrover.com. Over the last few weeks we've been finishing up a lot of the Land Rover mechanicals. Whilst the gearbox and engine are split, I took the chance to replace the rear crankshaft oil seal. It's a simple job, but you do need to drop the sump an inch or two, obviously with no oil in. And the new seal includes this guide that you put over the end of the crankshaft, and then you can slide the new one into place. It's a preventative job really, that should avoid us having to remove the gearbox in the future were it to fail, which is obviously quite a big job. We've pressed home a genuine Land Rover clutch spigot bush that had been soaked in engine oil for 24 hours and also cleaned off the mating surfaces of the engine and the gearbox before fitting this black gearbox shim plate. The dual mass flywheel can be located onto the crankshaft, tightening the bolts by diagonal selection to 40 Newton meters, which is about 30 foot-pounds of torque, and then a further 90 degrees, the reason being that these bolts are torque to yield fixings. Using brake and clutch cleaner, the clutch cover was wiped down thoroughly. And using a clutch alignment tool, the cover and friction plate were lifted into place. These nuts, again, are torqued down according to diagonal selection, which is a posh way of saying a star pattern. Before rejoining the LT230 57D transfer box to the gearbox, we removed the old mount to aid installation later. It's also much easier to fit the transfer box to the gearbox if you stand the gearbox on its bell housing on something soft like this carpet covered wood that we use, and using two people then you can just lift it into place. A lot easier to align, much less lifting and grafting to get it to sit correctly. We can now fit our moving clutch components, starting with a new centre release bearing guide. I somehow misplaced my old one, another costly lack of organisation there. I lightly smeared some molly grease on the push rod and secured that to the clutch fork. Do not forget to fit the pivot cap. The clutch release bearing is next in place, making sure to fit the clutch release bearing retaining clip into the fork and the designated slot on the back of the bearing. And finishing off the pivot mechanism with the clutch pivot clip. Now we can use the engine crane and sling the gearbox securely underneath it. We want to lift the gearbox effectively as though the bell housing isn't there because it weighs very little, so run a strap diagonally to try and get as even a lift of the gearbox and transfer box as possible. We carefully inch the gearbox into alignment in all three axes, and this is a lot easier again with two people to hand because you can have one on the engine adjusting that, the other on the gearbox, one operating the crane, etc, etc. We've selected first gear so we can turn the handbrake drum and mesh the splines of the clutch plate and the output shaft of the gearbox together and then bolt the whole lot down evenly. Finally, with those two secured together, we can lower the gearbox into place. We replaced the original gearbox mountings for new components and fitted those to the chassis. Afterwards, the gearbox is lowered into place and bolted up with 8 fixings on the underside. The old slave cylinder and hoses were quite grubby and slightly corroded, so we swapped these for new replacements. I've also put a pen lid on the top of the hose to stop any dirt or dust getting in there and contaminating our clutch fluid. And that is the reconditioned gearbox secured in place. I want to get the props fitted now, so I'll start by jacking up one side of the vehicle. This makes prop shaft fitting so much easier because you can rotate the output flanges the prop shaft mounts to and get optimum access to each prop shaft fixing. These are Hardy Spicer OEM style props distributed by Britpart. As per the workshop manual, we're placing the sliding joints towards the transfer box on both the front and rear prop shafts. I'm applying a small amount of molybdenum grease, or moly grease, on the fixings to prevent them from seizing in the future. We also replaced all fixings with 3/8 UNF nuts and bolts. A prop shaft nut tool is invaluable in undoing and torquing these nuts, otherwise you can wing it by using two 3/8 spanners, or even 14mm spanners will work, and the correct torque setting is 48 Newton meters. We can now move on to the engine, replacing the oil cooler gasket. Don't forget to clean the surfaces first. We had a lot of footage of these components being assembled together, however I managed to format my storage card accidentally, so I apologise for that. The inlet manifold was put through a dishwasher in the end, which covered everything inside with a slimy black oil. Not a good idea, don't recommend it. In the end, we used our parts washer from SIP Industrial to clean up the inlet manifold. We also cleaned up the centrifugal oil filter housing on the wire wheel and remounted our painted turbo and the fuel cooler. A while ago I talked to you about the exhaust manifold and how it had warped. It's a common problem with the TD5 for some reason. They just seem to, unfortunately due to the exhaust gases themselves, actually warp and this snap studs. Now this had happened on the two outermost studs. They'd snapped off inside of the hull, which was annoying. Sometimes they snap off protruding, you might be able to get a nut or an extractor on there to remove them. What we had to do in the end was, well, we tried two different techniques. This bottom one here was drilled out, and that's fine. We didn't have to helicoil it or anything like that, which is a thread replacement product you can get. All we had to do was drill it out. We managed to chip out the old stud and then re-thread it, re-tap it, and that is actually spot on, that stud there. This one here was slightly harder, and in the end it had to be welded. So the way this works is we built out what was left of the stud with weld, and then we're able to weld a nut on and then undo it, and that worked well. The heat of the welding cracks any corrosion or anything that's holding what's left of the stud in place, and you can remove it like that. Some people have had success by drilling smaller than you need to do into the stud and then using a stud extractor, but I didn't have any success trying that. Mine were fairly well stuck. So then, to solve that ever happening again, the theory is that because it's warped once, the metal shouldn't warp again. It's kind of gone to where it wants to be, and all I needed to do then was have that skimmed. Took it to a local machine shop. I think it cost £90 to have this surface here, the mating surface, skimmed flat and made right, and that should last us now. That's spot on really. You can buy expensive stainless steel replacements for £600–700. You can buy pre-modified ceramic coated exhaust manifolds for a couple of £100, or you can just modify your old one. Some people go as far as well to remove this casting here, this kind of webbing. I haven't done that myself. I didn't really see the need to. I think it adds strength. There's a reason it's there. Also, what I've gone ahead and done is order some spacers. So you can get kits online that give you longer studs and also spacers like this to hopefully kind of distribute the heat through the stud, stop the stud snapping. This should kind of act as a heat sink for the stud, and they're quite expensive kits. So what I did instead was I bought some stainless steel, or you could use an aluminium spacer online. This one's a 16mm spacer and it seems to work just perfectly. I also got some extended studs. The idea behind these is that because you've got extra length, hopefully there should be more give in the whole setup and you shouldn't snap any more studs in the future if this does have a degree of movement in it. These are from Worth. I bought them on eBay. I think they were only about £15 for the whole kit to replace all 10. I also coated the exhaust manifold, the turbo, and a few other high temperature components with Frost high temperature enamel pin, which we used on the engine block. It's a very similar product, except this one goes a lot higher, and it kind of really was only a cosmetic thing in this case. Stud removal is very easy. Simply run one nut onto the stud, followed by a second, tighten them against each other so that they lock together, and then slip a spanner either over the joint of the two nuts or over the rearmost nut, and then you can undo the stud. And that can be done in reverse to fit new ones. And that's it for this week. Next week we'll be fitting the stainless steel straight through exhaust, flaring up a whole new set of brake pipes, and welding our bulkhead. See you next week. We hope you've enjoyed this episode of FunRover TV. You can see our last episode here, and also check us out on funrover.com. We are at FunRover on Twitter and Instagram, and we're also on Facebook.